Bismillahirrahmanirrahim. Assalamu alaikum, dear students. My name is Ali. I'm your physics teacher, and in today's lecture, we are going to discuss a topic of physics of ninth class, chapter 5, gravitation. Our topic of discussion is mass of Earth. In this topic, we will be able to learn that how we can find or calculate the mass of Earth. For this purpose, students, we will use law of gravitation, as we know the relation in the previous lecture, that how we can find the force of gravitation between two objects by a relation. Then for this purpose, we have a consideration that consider a body of mass m placed on the surface of Earth. Let me be the mass of Earth and re be the mass of radius of Earth, and the distance between mass and center of Earth is nearly equal to the radius of Earth, because the distance of object from its starting point to its center is much smaller than the distance from the surface of Earth to its center is much larger than this. So we can neglect and we can take the distance between the centers of two objects. One is Earth and other is the object which is placed over the surface of Earth, is approximately equal to a radius. So according to the law of gravitation, we know that F is equal to G m1 m2 by d square. So here we will take G small m for the mass of object over Earth, capital M E for the mass of Earth, and d square we will take r square. And students, we know that the force which an Earth exert on a body is equal to its weight. So according to the relation, force will be equal to weight, and we know that weight is equal to mg. So we can put the value of W is equal to mg in place of F. Students, in the next step, F will equal to W is equal to mg. We will put the mg in place of F. It will be equal to mg is equal to G m e over r square. Students, here you can see that small m is present on the left side of the equality and on the right side, so it will be cancelled, and next relation will be G is equal to G m e over r square. So rearranging for the finding mass of Earth, we can write it as me is equal to r square G by capital G. Students, we know the value of capital R, radius of Earth, G gravitational acceleration, and universal constant G, that R is equal to 6.4 multiplied 10 raised to power 6 meter. The gravitational acceleration is 10 meter per second square near the surface of Earth, and gravitational constant has the value 6.673 multiplied 10 raised to power minus 11 Newton meter square per kg square. Students, by putting these values in the relation, we can get that me is equal to 6.4 multiplied 10 raised to power 6 whole square multiplied 10 divided by 6.673 multiplied 10 raised to power minus 11. So we have to take the square of 10 raised to power 6 separately and 6.4 separately. So it will become solving with multiplying with 10 also 4.096 multiplied 10 raised to power 14, and the denominator is 6.673 multiplied 10 raised to power minus 11. Students, by solving these values, taking the 10 raised to power up, it will be subtracted from 10 raised to power 14, and dividing 4.096 to 6.673, the answer will be 6.1 multiplied 10 raised to power 24 kg. So student, this is the way that we can calculate the mass of Earth. So I am revising shortly that how we can calculate. We have to consider an object placed over the surface of Earth, then we have to take distance between them is equal to the radius of Earth, and we have to use the relation of finding the force by the law of gravitation, F is equal to G m1 m2 by d square, and then taking the force is equal to weight, and then putting the value on the place of force, then rearranging and putting the known values, we will be able to get the mass of Earth. Thank you.